human body is designed to work. We have a standard operating procedure, if you will, right? Or original manufacturer specifications, right?
Yeah.
It's designed to work.
Right.
And when it works, you're healthy. When it doesn't work,
True.
you're not. Health is actually the most studied of human conditions, because every time we do a study in multiple sclerosis or Parkinson's, you're always going to have a control arm or a healthy arm. You're going to compare the Parkinson's patients to a healthy patient. And so we always have this healthy background. So rather than trying to diagnose Parkinson's, all we have to do is actually say, here's what health should be. And actually need to measure when we deviate from health. It's like checking the oil in your car. Okay, I don't have to wait for the engine to fail. I can just check the dipstick and say, well, the oil is low.
Before the show started, you were talking about, you think that the human body should live to 150 years old, or it's possible.
I think it's indefinite.
Can you talk about that?
Personally.
A little, not in too many technical terms.
Well, the biggest thing people think of is that they have the concept of aging wrong.
Hi, welcome to the Dr. Dana Show. I'd like to ask you a few questions before we start our show today. Have you or anyone had a relative walk off from a property that is definitely, they know where they're going, they know the whole area, they've been there before, and get totally lost, as well as not even know who they are? Or have you ever been looking through a photo album, an old photo album with a relative? You're going page after page, looking at many pictures, and the relative looks at you with a blank stare, sadness in their eyes, because they don't recognize anyone in the album? Well, this is because a lot of this is happening because of Alzheimer's and senile dementia in our society today. Every 65 seconds, there is a case of Alzheimer's diagnosed in America today. We also have over 10 million people with the disease, which is completely bankrupting our medical system, bankrupting families, bankrupting the whole society, because many times the Alzheimer's patients, as you well know, don't die right away, and they live for a long time. They get worse and worse and worse, and they need 24-hour care. Well, today we have an amazing warrior, a pioneer, who's been looking into this for many years, working on this, Dayan Goodenowe, PhD, who is a neuroscientist and works in psychiatric medicine for many, many years. And his whole mission in life is to solve this problem, and he's doing it right now. So welcome, Dr. Dayan Goodenowe.
Thank you, Dr. Dana.
Thank you for coming on.
Pleasure to be here with you.
So let's tell everybody what you've been doing. I know I went to your labs in Temecula. He has some of the most profound advanced labs in the country. He can diagnose different kinds of cancers, many neurodegenerative diseases, many years before these things even take place. And so how did you even start? How did you come across these ideas? Because these are abstract. Nobody seems to, I talk to doctors that are, functional medicine doctors who are very, very bright, and they say, Dr. Goodenowe, I don't understand anything he's saying.
Yeah, well, you just don't just fall into this, right? So I'm formally trained in synthetic organic chemistry and biochemistry. My PhD is in medicine, looking at the biochemical mechanisms of psychiatric disease. And so this is where my core structure is. As time goes on, in the 1990s, this whole genomics revolution was taking place. Like we were sequencing the human genome, and there's a gene for this and a gene for that. And we had technologies that could measure virtually all genes and all gene
like
expressions.
CRISPR.
But the human body is biochemical, right? Like we have a metabolism that, we eat. We are hydrocarbon burning organisms. Like we generate carbon dioxide and water, and we burn fuel. And we build, like you eat a hamburger and a milkshake, and your body makes hair and bone and muscle from that stuff.
Fat, too.
Right, and fat. And so my first real invention in the field was this non-targeted metabolic profiling. So we use it.
Which means what?
Basically, we use an advanced ion cyclotron mass spec that can monitor all the biochemistry in the body simultaneously. So measure thousands and thousands of biomarkers. And the intention was to use this technology to diagnose disease, which, as you mentioned, I've got all these patents in diagnosing colon cancer and pancreatic cancer. Mm. And the premise was, if you have a tumor, like if I'm sitting here normal and you're sitting there with a pancreatic tumor inside of you, like that tumor is doing something to you, right? Sure. It's got to have some sort of biochemical.
Well, it's throwing stuff off into the blood or the urine or the stool that we could possibly measure and see it in advance, way before it starts. That's what you're doing.
Exactly. Right? And so we figured if you had the right advanced technology, it would be quite easy to understand if someone had cancer or not have cancer. Okay. And so I invented this technology and patented it back at the end of 1999. And so then we used this technology to look at epidemiological studies, like people with cancer, not cancer. Mm-hmm. And it was very powerful. We could diagnose, we're measuring thousands and thousands of biochemicals in your blood. And it was very powerful at diagnosing someone with, say, colon cancer. And then we thought, okay, well, it's great. We can now measure biomarkers associated with colon cancer.
Can you measure before you get any kind of tumors forming, even the smallest tumors?
Well, see, this is where the aha button or light came on, because we did the study in Osaka, Japan with colon cancer before and after colon cancer removal. So we got the blood test, high diagnostic and the high, 98% diagnostic. And we figured soon as the cancer was surgically removed and, 12, 16 weeks later, the person was considered normal, that these biomarkers would come back to normal.
Sure.
They didn't.
Really?
Right. And so exactly.
What happened?
Well, we didn't understand. So why are these biomarkers still
So
low?
the tumor is not the cancer, it's the end result of the cancer?
Correct.
Okay.
And so we quite frankly, we didn't believe the results. So we redid the whole study over again in another university, in Chiba University, Japan, and got exactly the same results. And this is when it really started dawning on us, and me in particular, this concept of prodromes, that there's a deviation from health that precedes.
So a prodrome is what? It's like the beginning of a disease and you can't see it?
It's that which comes before.
Okay.
Prodrome is like a bald tire before you get a flat tire.
Well, it's also when they have the migraines, they start to see lights and things like, right? The
Exactly.
Okay.
And that's when it really became clear that we're missing a concept here, that rather than chasing a disease and trying to say, here's a disease, here are biomarkers of a disease, here is health. Human body is designed to work. We have a standard operating procedure, if you will, right? Or original manufacturer specifications, right?
Yeah.
It's designed to work.
Right.
And when it works, you're healthy. When it doesn't work,
True.
you're not. And so the question is, we don't really have to measure disease. We just have to measure deviation from health. And so when we started doing more studies, and the bigger one was in the dementia space, looking at people with cognitive impairment, at different levels of cognitive impairment. And using this technology, identified these molecules reproducibly decreased in the blood of individuals with dementia. And the more severe the dementia, the greater the decrease of these biomarkers in their blood were. And of course, this technology measures everything, even if you don't know what it is. And so we had to discover what those molecules were. And it turned out these molecules were called plasmalogens, which is something that no one's ever heard of.
So wait, you were measuring these molecules, but you didn't know what they were, but you're seeing that everybody who had this disease or some kind of senile dementia or Alzheimer's was having a problem, like across the board. This was always coming up in your lab, right?
Yeah.
And you're like, what is this
What
thing?
is this thing, right?
So you're like going backwards.
Yeah, basically get the chemical structure of it. I Googled the thing,
Wow.
right? Figure out what the hell this thing
Sherlock
is.
Holmes of biochemistry.
Totally what it is, right? And plasmalogens, I'm going, and this is where it gets really quite shocking.
Plasmalogens, right? That's what you're saying?
Plasmalogens. And I didn't invent them. They were actually discovered back in like 1919. And we knew about their importance back in the 70s because there's certain children with genetic diseases that affect this plasmalogen. And we're not talking about small, they're not trace levels in your body. 20, 30% of the lipids in your brain.
Really?
50% of the lipids of your heart. Like we're talking a core component of every single cell of the human body is made up of these plasmalogens. Mm-hmm. And we'd seen them before in postmortem studies decreasing,
Right.
but it was always assumed that they were happening after. Like you had infection or you had inflammation or you had oxidative stress, and it was taking these molecules down. And so the research that I was doing in these epidemiology studies was showing that these were going down first. These were predictive of
So
future
it wasn't
events.
the disease that was making them go down.
No, they were going down first.
What was it?
Probably reduced function, reduced activity. They're highly documented molecules that decrease with age.
Can you eat them?
That's the big problem. You can't because they're not biologically available. There's no real natural source.
So the body has to make them. Like some amino acids, your body can make others you have to take every day,
Yeah.
like vitamin C.
So it's an essential nutrient, but the body is capable of making a lot of it. The only place that we see it in the natural food supply is in human breast milk. So human breast milk contains high levels of these plasmalogens, and they're used to help the baby develop the white matter, so early brain development. That's why we see these lower incidence of autism in breastfed babies versus non-breastfed babies and brain development.
Only because of plasmalogens? There's a lot of things in breast milk, right?
But it's mostly the plasmalogen content
Really?
because it's the myelination of the early development of the brain.
And plasmalogens make the myelin sheets?
So plasmalogens are what you call a phospholipid. And so your body is made up, like you're not a bowl of soup, right?
Right.
You have structure. And what causes the structure is that you have, it's like a big apartment complex with all these different cells in it and built, rooms. And we call those little rooms cells in the body. And you have like 30 trillion of them. So it's not a small amount. It's like a lot.
Yeah.
And every one of those cells has walls or membrane And that membrane, what the body uses to make a biological wall, if you will, is called a phospholipid. And phospholipids are like soaps. Like, when you try to dissolve oil in water. And so what happens then, these plasmalogens make up a big component of that. So these membranes create this phospholipid bilayer where two of these phospholipids combine, and the fatty acid side chains, the oily part, sticks in the middle, and the polar part stick on the outside, and you create basically a wall that separates things. And so plasmalogens are part of that wall, and they determine whether they're fluid or whether they're impervious. And so,
talking a little bit, the average person's not going to understand what you're saying right now. So just lead that into, say, disease states and how you're putting Alzheimer's or senile dementia into remission, and what you're seeing from these patients, what the changes are, or autism for that matter. I know you do a lot of work with autism, right?
Absolutely, with autism, multiple sclerosis, Parkinson's, dementia. But I think the reality is, though, for everyone to understand, is when you're thinking, that's a communication. It's like the lights going on and off, right? Right. But there's a switch, right? There's like when your switch is off, you have the wires, but the electricity is not going through the wires. Then you turn the switch on, and electricity flows through it.
Sure.
And that's how your brain works as well. But your brain isn't made of copper and metal, right? And so it's made of natural materials. And so when one brain cell communicates to another brain cell, it does it by releasing neurotransmitters. So people have heard of noradrenaline or serotonin, 5-HT, those are called neurotransmitters. And what they do is they're like the switch in a light switch. They pass from one neuron to the next neuron and turn the next neuron on. But in order for those neurotransmitters to get released, they actually have to the membrane has to open up and let them out. And when the membrane gets deficient in plasmalogens, it gets too stiff. So in cognition, when you have low levels of plasmalogens in your brain, the ability for your neurons to release neurotransmitters is impaired. So you really have a clogged up system. It's like you have rusty wires.
So when you say that, it starts to remind me of a film. I don't know, a lot of people, I'm dating myself, but it's a long time ago called Lorenzo's Oil.
Correct.
And the whole family watches. This is back in the day when your family actually watches movies together. And it was wonderful. And we cried. It was a very powerful film. Is that something like what you're doing now, what they were doing for that disease, fixing the myelin sheaths with, I think it was oleic acid, was it olive oil or something like that?
So Lorenzo's oil, so the disease that was studied there is called X-linked ALD, so adrenoleukodystrophies. These are inborn errors of metabolism.
Do you work with those diseases as well?
Very much, actually. And so we have a very big charity in children with demyelinating diseases. Most people understand these inborn errors of metabolism. So every mother and father who has a child, their baby typically gets a little heel prick, they get a little piece of blood, and it gets sent in for biochemical testing. And that's actually a mass spectrometer. So it's kind of like what we do, really. And they'll look for all these metabolic disorders. And these metabolic disorders basically identify if genetic problems, they can't make certain molecules.
Or others may be making too much.
Exactly. So Lorenzo's oil and X-linked ALD, which happens only in boys, the issue is that the peroxisome, part of the cell, is not working properly. And they were kind of trying to bypass it using a special fatty acid called Lorenzo's oil. And so the plasmalogens are like that, but a little bit different. What it does is it provides the building material to your cells and allows the cells to complete their job. And it's like you're building a house, right? And you don't want your carpenter to have to go out and actually, fell the trees and make the lumber. Like if you can actually just give them the lumber, they can build a house. But if the carpenter has to spend half the time making the lumber and not using the lumber, then you've just created additional work and stress, and it slows down the building of the house. And so when we're talking about biochemical restoration, and we're talking about enhancing human health or restoring it to its normal function, it's basically rebuilding that membrane structure.
Hold that thought, because I read something you wrote, I can't remember the exact words, but it was about that biochemical restoration versus what we're fearful of disease, and we're taking disease very seriously and we're scared of it. Can you talk to that? Because I think the public in general needs to understand these concepts of healing, because I used to think, oh, these concepts are interesting, but no, they're not interesting. They're actually how you're going about diagnosing and treating people too. It's a complete shift in thinking from the allopathic medicine we have now.
Correct. Well, and you have to remember, most of human life we've been focused on not dying early from an infection, a viral infection, or an injury. Most people died relatively young.
Heart attack. I mean, that's
Exactly, these
usually-
things. And most of the worst things that happened to healthy people were some sort of bacterial or viral infection. And that's some sort of external source being put on you.
Okay.
And then you get inventions of penicillin. So you think, wow, if I can just go in and kill the bug,
Yeah.
I'm going to be fine.
Right.
And then that gets stuck in your head long term. So you think every disease, you think Alzheimer's or these amyloid plaques or tangles.
Yeah.
That,
Just kill them, get rid of them, and you'll
right.
be fine.
Like somehow that's been put on you, right, from the outside. And the reality is it's the other way around. Okay, you actually, the formation of amyloid plaques is because the memories have lost their healthy function. Formation of these neurofibrillary tangles.
Membranes have lost the function.
Exactly.
Okay.
And so when you restoring function is the cure. And what really was a breakthrough on this is that health is actually the most studied of human conditions, because every time we do a study in multiple sclerosis or Parkinson's, you're always going to have a control arm or a healthy arm. You're going to compare the Parkinson's patients to a healthy patient. And so we always have this healthy background. So rather than trying to diagnose Parkinson's, all we have to do is actually say, here's what health should be. And actually need to measure when we deviate from health. It's like checking the oil in your car. Okay, I don't have to wait for the engine to fail. I can just check the dipstick and say, well, the oil is low. Okay, so I know what the oil is supposed to be, and I don't need to say, well, it's fine until it starts making noise. So understanding how the health deviates from optimal function.
Okay.
Then that leads to the next part is how do you restore it back?
Sure.
Right? And this plasmalogen story was uniquely interesting because, you think about it, right? You have lots of plasmalogens in your body, like your muscles, your heart. And so if you're eating animal products, by definition, you're eating plasmalogens. So why can't I get plasmalogens from a regular dietary supply? And the reason is that when your body makes them, they're extremely sensitive antioxidants. So they're the body's primary mechanism of reducing oxidative stress, like peroxides and things, which means when your body makes them, the very last step creates a special bond. It's called a vinyl ether bond, but it's very sensitive to acid.
Oh, so the stomach will burn
So
them
as
up?
soon as you eat it in the stomach,
Inject them.
Well, that's possible, but you still need
Like
lots of
vitamin D, you can inject. It's a fatty acid, right?
problem
too many.
but vitamin D, you only need a few milligrams. You need grams of plasmalogens.
So you protected them with some kind of enterogenic coating so it gets through the stomach?
No,
or-
it just creates a precursor. Like this is what's so
okay,
exciting.
okay.
Nature is very smart. Okay, so human breast milk doesn't actually contain plasmalogens. It contains plasmalogen precursors.
Tell the public what's a precursor. What does that matter?
It's something that is used that then converts into the final product. So for example, when you take niacin as a vitamin, okay, niacin isn't NAD. Niacin is a precursor to NAD.
Okay.
And so, or people, if you have friends or family that have Parkinson's, for example, they'll take a drug called L-DOPA,
Sure.
which converts into dopamine. So you don't actually take dopamine, you take L-DOPA, which is a precursor to dopamine. So often we have these things that are precursors so that they go into the cell that needs them, and that cell converts them to the product as required. And so that you supply it into those systems. So that's what a precursor is. And so human breast milk, for example, is exquisitely designed for the human baby because it has these precursors. And it's designed to go into the baby's brain and help that baby develop the myelination. Because when you're born with very little protective coating. So I say this word myelination.
So you have wires that
What
are
is that?
encoded,
Yeah. So all the wiring in it's called an axon from a neuron perspective, but it's like a copper wire. And your body also creates this plastic coating around it
Right.
to protect it, to ensure the signals can go long distances. Well, of course, we don't make plastic, so the body makes what's called a myelin sheath.
It's fat, right? They're
Yeah.
fatty acids, right?
And when you're born, all this wiring is raw wiring because your baby doesn't really know which connections are working, which ones aren't. And so what happens as soon as a connection gets made, so as you see a little baby get their dexterity gets better, and each time that happens, that wire gets protected. It's, okay, that's a good one. I'm going to keep that one.
Interesting.
And it myelinates it. And that whole myelination process takes a lot of plasmalogens. And so you start, and this is why autism mostly get, in the 18 months to 4-year period is the highest risk window of autism, because that's when the brain is doing the most amount of
Interesting.
myelination.
That's why that period of time. Okay.
Because when you're born with maybe 5% myelin. You and I have 60% of our brain is myelin. So first part of this problem solving of plasmalogens was, how do we restore them? And that's my next major level of inventions, was these plasmalogen precursors. So I invented them way back in 2006.
And you're making these now, you're selling these as a product, right?
So we published all this work, and we showed that we could selectively elevate plasmalogens. And we have two types. We have the omega-9, which is used for the myelin sheath, and the omega-3, which is used for the synaptic function. And so those of you who are concerned about Alzheimer's, or they have an ApoE4 genotype, for example, the ApoE3 is very important, because that,
For?
the omega-3 plasmalogen, because that's what's involved in the synaptic functioning, to get people's memory back.
If you have an ApoE4, it's a genetic test we test a lot of times. Those are a lot of times in the past, we would see a basketball player die on a court instantaneously. They would fall down to prime of their life. A lot of times they had these high ApoE4s, but we didn't know what it was until like the last 5-10 years. As well as the ApoE4, I think it's like 75-80%, almost for sure will get Alzheimer's, correct?
Yeah, it's a higher probability,
Very high probability, yeah.
but it's not definite. My own personal experience.
Well, you can circumvent this but if you eat McDonald's and you're going and drinking a lot of alcohol and you're not taking care of yourself,
correct.
That's going to help it along.
Like if you randomly do nothing, if you are an E4 carrier, you have 2 to 3 times higher risk of getting Alzheimer's than someone who does not have E4. So it's definitely an increased risk factor, 100%. It's probably one of the strongest risk factors. It's right up there with the BRCA gene for breast cancer.
Right.
Like, it's a very, very powerful risk factor. And so understandably, people are concerned if they go for genetic testing and they get an E4 test. They don't really understand what it means. But you can, like, we published this work. So people who have high plasmalogens in their blood have no increased risk of Alzheimer's.
Even with ApoE4?
E4. It neutralizes the E4 risk of Alzheimer's. The Alzheimer's risk happens in your 60s and 70s. So it corresponds with the decrease in plasmalogens as we get older.
So everything's coming back to this plasmalogen?
Well, it was crazy, because, so I've written about it in the book extensively, but so we're doing these studies. So first of all, when you find these plasmalogens, you say, wow, is this a symptom, or is it cause or effect?
Right.
Like, what's going on here, right? And so we do these longitudinal studies. And one of these big longitudinal studies we did was with Rush University in Chicago, where we looked at people over 17 years. They enter the study cognitively normal. They will get dementia at some point in time, like everyone does. And we can track their blood work before they get dementia and after. And so the question is, can we predict people? If you're normal right now, cognitively normal, but you have low plasmalogens, what is the probability that you will become, or you will get dementia in the next 3 to 4 years? And we showed that if you had plasmalogens, it increased your risk of dementia by 3, 4, 5 times.
If you didn't have enough?
Yeah, if you're low. And so it was clearly predictive. So it's a causative pathway here. But what we didn't realize at the time, so serendipitously, like, this is an elderly patient population. So over 17 years, people are dying, as you would imagine, right? And so we looked the question, well, what's the relationship between blood plasmalogens and all-cause mortality, for example? And that was extremely shocking, because it turned out it was a 30-year difference in your 5-year mortality. So a 65-year-old person with low plasmalogens had the same 5-year lifespan as a 95-year-old with high plasmalogens. So a 95-year-old who had high plasmalogens had the same probability of living to their 100th birthday as a 65-year-old with low plasmalogens.
That's huge.
It's huge. And it was so the all-cause mortality association was extremely more strongly associated with just death than dementia. And so this was a real eye-opener for us, because we see these plasmalogen deficiencies in all cancers, for example, in Parkinson's, multiple sclerosis, this COVID epidemic that we're dealing with, lots of publications showing COVID specifically reduces plasmalogen levels, because the heart inflammation, like when your cells get inflamed, they dump plasmalogens out of the membrane to douse the flame. Okay? And so really, like, we're here in Southern California, and so if you have low plasmalogens, it's like being in the Pacific Palisades and have no water in your reservoir. Basically, when something bad happens and you don't have any plasmalogen reserves, you can't put the fire out. And this is really what happens to the human health over time, because, this is where risk factors come in. Like, you can have, risk, like an E4 or other things, but you still need some sort of trigger in your life, typically, right? Something happens that
Well,
really
it's all the
kind of
chemicals, the foods we're eating,
Exactly.
the stress we're under. So many different things are coming in
Yeah.
these days to cause massive inflammation.
This natural progression, A leads to B, B leads to C. So it starts with this ion cyclotron technology, identify these biomarkers. Plasmalogens are one of many of critical components, but it seems to be a really heavily weighted system. And then now we're doing these advanced MRI technologies, so we can actually track the human brain. And so we can look at, so now we treat people with multiple sclerosis, for example. So one of our clients has been blind for 30 years, okay, with optic neuritis, multiple sclerosis. We started treating her with plasmalogen precursors, and she's now can read 5-6 lines on an eye chart.
Amazing.
After 30 years of blindness. And we can use advanced MRI to map the regrowing of her brain. And same thing for me, I'm unbeknownst to me at the time, I was suffering from post-concussive syndrome. I thought I was fine. I had a bad head injury when I was a young child, around 6-7 years of age. I thought I was fine. Was in the hospital for a week.
Wow.
And
now you speed it up till now you're in 50s?
Well, yeah,
and
so
you
I'm
have
in
problems
50
now?
So I'm 56 now. So I went and I started doing this advanced MRI technology and developing
But
it.
if you hadn't done the MRI, would you know any of this?
No. I thought I was normal, right?
But it might take we might have a problem down the road because of this, so now you found it.
It was definitely a ticking time bomb. This is what happens. A little bit of brain inflammation can be okay.
Yeah.
Which is like these autistic children or bipolar patients, for example. They're really high functioning. They're running at high RPMs. And so a little bit of inflammation of the brain is actually, quite enhancing in some ways, because your brain has to, like the old cliche, that which doesn't kill you, make you stronger.
Oh, interesting.
Right?
Okay.
But you can't do it forever, right? So it's for short periods of time. So I basically dodged a bullet because the MRI was showing this inflammation. I thought it was fine, but this was going to eventually have an effect on me, like people with sports injuries, right? So some of our highly functioning
TBI?
Exactly.
Okay.
And so
what you're saying is even after the TBI is over and they seem everything's normal,
they're not normal.
They might have this inflammation that could lead to Alzheimer's or dementia.
Very rarely are they normal. And we know that because, so if you have a history of concussion, your risk of future concussion goes way up. Okay, so there's no ambiguity in this situation. So previous head injury puts you at higher risk for future head injury, which tells you exactly that injury, that original head injury has not healed itself. And a lot of MRI studies can show that now, that people, this is why the brain is very adaptive. Okay, it's there to survive. It's there to help you survive.
Oh, yeah.
And so it's going to find a way. It might not be the best way, so it can trick you. You can be tricked into thinking everything's fine, like in my situation, because it'll find an alternative way to get the same job done. But over long periods of time, that can catch up to you. And so this is what happens to these athletes. They're the prime human specimens of our world,
Sure.
right? And they don't age so well, right? And the issues that they have later on, some of these head injuries are...
So it's not knees, it's brain a lot of times. So you need to take this to all the high schools in America and sell your plasmalogens. I mean, every football team, literally.
And hockey in Canada. So
Right.
absolutely. So we're doing a lot of effort on that. We've treated a lot of kids now,
Really?
with hockey injuries. And I'm going to be doing a big lecture on it because one of my nephews, a great nephew of mine, has a head injury. And so we're going to be tracking him over time. You got to take these things seriously. I think we live in this, it's one thing when there's nothing you can do about it, right? So don't worry yourself. Like this is what ApoE4 is a good example. People are still not recommended to get the blood test because traditional science or medicine says...
Even in their, we're doing it for everybody. I check on every single lab.
That's not standard medicine.
I know, we do functional medicine, but...
Right. You're doing advanced medicine.
We have 10 pages, yeah. We want to look at everything, at least once a year. They can do small bits and pieces to recheck things later on, but we want to get the big picture. At least I do. I don't want to be in the dark because I know. See, if you don't know what you don't know, then you won't do it.
You can't do anything.
You got 2 pages, you get 4 fats and a glucose, and half of them have heart attacks. Well, why is that? Because there's 7 inflammatory markers you need to do. Every single marker in here is going to have something to do with you now or in the future. Let's do it once a year.
Exactly.
At least see.
And then deal with this restorative process. Like the human body, this is why we do the proton scan blood testing. We look at...
Talk about that. What is it? What's it measuring? I mean, I saw it, and I'm not attuned. There's a lot of fatty acids on there. I know that much.
Well, all these like tens of thousands of blood samples that I've analyzed over the years, and all these different diseases, and all these different diagnostic procedures that I've developed. Over time, it started creating a clearer and clearer picture of how many core systems are really important to be operating in the human body.
Biochemistry. You're talking
Biochemistry,
about?
right?
Okay.
And it tells you, like when we're measuring your blood, it's like measuring the tailpipe on your car. Okay, if your engine's running smooth,
I thought
the
that was a
exhaust is
stool
smooth.
test.
Or a breath test or whatever it is. But anyway, it's measuring how the combustion of your body is working, right?
Okay.
And so when you're doing this, you can measure how the body is working. Okay, so your phospholipid levels, like these plasmalogens, phosphatidylcholine, like we're one of the few labs that actually measure phosphatidylcholine.
Which is lecithin.
Right. It's very important to know. We have certain molecules from the gut microbiome that we measure that are really associated with cancer, colon and pancreatic cancer. Your methyltransferase system, mitochondrial system, cholesterol
And we're not
transport.
measuring those on regular labs now?
No, nothing like that. And so there's actually not that many. So the test, it's a couple pages, but it deals with these core systems that need to be working properly. And they're highly predictive of adverse health consequences. And so these are just simply understanding deviations from health. And so we want to look at those main things, and we want to put your health in reserve capacity. Give you you want to get a biochemical savings account.
Interesting.
And these are the things that we work on the restoration of health. And when you do that,
So it's
people
huge
get better.
prevention, massive prevention you're doing.
And it's vitality.
Yeah,
So when
okay.
you talk about the dementia side of the story, people start having conversations with their loved ones. People, I remember when.
Talk about specific patients if you can.
Yeah, so one was funny, siblings. Of course, obviously you're dealing with children of dementia patients a lot, and then spouses, right? And so there's one story with the two siblings were talking to each other, and says, "Yeah, I had a conversation with my mom the other day," and the other sibling said, "Well, yeah." I said, "No, I had a conversation with my mom the other day." Right? And so it's a very different, this back and forth. People actually understand. They remember the previous conversation.
Right.
They start, dealing with their world around them. They start taking executive action again. And we treat all these situations like a trauma situation because the caregiver, people, when you're married and you go through life together, you live an independent relationship. Each partner in the relationship is independently contributing to the whole of your relationship, right? And when one person starts suffering from a chronic disease, that relationship goes to a codependency, right? And the dementia patient, they know they're functioning less and less. They know they're relying more and more on their caregiver or their family, right? And there's a bit of guilt associated with that and so there's that relationship changes. So when you start restoring people's cognition, okay, it's not just all sunshine and lollipops because now people have to relearn. They need to relearn their independence.
Okay.
The caregiver says, "I'll just do everything for you because you don't know what you're doing," right? And so they'll make the coffee. They don't have patience for the dementia patient to kind of relearn how to do all these things, right? It's a concept, right? And oftentimes the caregiver becomes really, their purpose in life becomes attached to caring for this person. So they don't really want to give up and let that person become themselves again. So a lot of that is really important. And sometimes they start remembering things like that they don't.
But it's just a miracle, to me, that these people who are maybe catatonic or almost didn't even know who they were at one time, as I said in the beginning, would wander off and they'd end up in the police station. They pull out their wallet and says, "Is this you?" And they're like they don't even know. Correct. But to come back and start to have a conversation.
They remember pictures.
These are miracles.
They very, very much so.
It's
and they
so
start remembering the
powerful.
previous day's conversations. They remember, where they're leaving things. They become engaged with their environment. They're engaged with their loved ones.
All the problems after that,
but mobility is another big
tough,
thing.
But
people forget that cognition, especially dementia. When you go to these dementia wards, you'll notice it's not like a Parkinson's ward or other. Most dementia patients eventually end up in wheelchairs. So there's a very significant reduced mobility and sarcopenia in dementia.
What's sarcopenia?
Reduced muscle wasting with aging. And so we find these things go hand in hand. So when we restore the plasmalogens, we restore the membrane structure, and a few other biomarkers, that their mobility gets better. They
Just
start
like
walking.
cocoon?
It's kind of, it is.
Like
It's
cocoon.
really,
That's great.
It's really interesting. So these are truly things that we can interact with. So the neurological side, the multiple sclerosis, We do a lot of work in ALS, which is just a horrible disease. And
How
autism.
what's happening with ALS? Because even up until a couple of weeks ago, I thought that was just completely incurable. It was horrible. But you're having some people come back from it, right, and recover?
Well, see, ALS is a very challenging disease, and people misunderstand it a lot. Okay, it is a muscle wasting, and it's a neurodegenerative disease. And even myself, as we dig into this, like a lot of the initial learning and thought in ALS was that you get this neurological degeneration, and so then the neurological signal to your muscles stop happening. And so your muscles aren't actually receiving neurological input. And so your muscles waste away because they're not being stimulated, right, which is the muscle wasting part. And so when you look at restoring neurological function, which is what we do in all these other diseases, we're very good at that part, okay? The muscle wasting is another issue. What happens in other diseases. So ALS has these two components of it. And if you restore the mitochondrial function, you can stop the progression of the disease. And we've got numerous cases over and over and over again that people speak for the first time in 2 years, or they're moving a muscle for first time in 2 years. They're going off their ventilator, or their breathing gets better. The hard part for most people to realize if they're suffering from ALS, or they have a caregiver or someone they love with ALS, is there's significant damage that has occurred to that individual, okay? So even if you were to wipe the slate clean on day 0, okay, you're now dealing with almost like a sports injury.
So you're talking
situation.
about just fix the whole nervous system so it's given the right stimulus, but then the muscles have been wasting for so long, or they're flaccid.
Exactly.
They're not going to work.
There's a whole, the
So you have to
rebuilding
fix that too.
is a slow process.
So PT,
yeah,
physical therapy.
And it's a long game, okay? It's a psychological
You have a lot
game.
of patience.
Yeah, and then setting the goals appropriately. Okay, so we always try to get that first, 6 weeks or so. We should see some subtle improvements. Okay, that little movements, little things that just show, because you're theoretically you're not supposed to have any improvement, right?
Right.
It should be a continual decline phase. So any kind of little hint that some muscle strength or breathing is getting better means that we're moving, we're changing the trajectory, and then you kind of have to build it. I tell people it's like trying to light a fire in a hurricane. Like you kind of have to do slow, and you kind of have to build it. And the problem with ALS is so many of these people are young. They're very high functioning people, high preponderance of athletes or firefighters.
What's the etiology of ALS? Like, how do you get it?
Well, it's going to be,
Genetic?
there's small components genetic, but even the genetic versions have very, very different dates of inception, for example, right? So you can have a genetic risk factor, but there could be a 20-year differential when you might get ALS.
Sure.
So clearly there's an environmental component which triggers the ALS.
Not low plasmalogens? Really?
Well, low plasmalogens are in all the ALS patients, and I published that years and years and years ago. And it's because of this peroxisomal function. Now we're going to get in the weeds if we want to, because technically ALS is really a breakdown of this D-serine system. It's a hyperactive.
Too complicated. But
It's a hypermetabolic situation.
all right.
They've got this
So
glutamate.
but have you found like heavy metals or mold or viruses or anything triggering?
All of those things.
So it's like
All the above.
It's a whole soup. Huh?
We're seeing a lot of post-vaccination, post-COVID people that has triggered it.
So quick ALS is happening more and more after the
absolutely.
vaccinations?
Absolutely.
Like the turbo cancers?
Like the turbo cancers. It's just a stress on the system. Okay, the COVID, whether there's COVID or the vaccine, I don't really get caught up into it because it's a spike protein. It gets into your cells. It knocks down your mitochondrial function.
Right.
Okay, and so if you're kind of borderline to begin with, it just knocks you off the cliff.
Yeah.
Right. It's a stressor on the human body.
I got it.
Okay, and so it's we just need to restore that health. Like biggest issue with the COVID mostly is the myocarditis, the heart-related issues. Okay, that's the biggest brain fog, microglial inflammation. These are really the most documented.
So long COVID you're talking about?
Yeah, all these things because you get depleted. But back to ALS. Yeah, there's usually people that are in the firefighting industry or they're
full of chemicals.
Exactly.
Yeah,
so
there's the hardest to treat.
There is absolutely
smoke, chemicals,
the epidemiology
burning
data.
plastics. You don't even know what it's doing because a regular plastic in the system is one thing. Now it's burning, so that completely changes it.
But the point is too in this is that not everyone exposed to the same toxins get the same diseases.
That's hard.
So people think, oh, these toxins are bad, which they are.
Yeah.
Okay, but that doesn't mean you can't overcome them.
Sure.
And so we did a lot of work on this. So when we do animal studies, okay, we use toxins that you will never get exposed to in your daily life. Okay, so we can create demyelination of the brain. So we use a toxin called cuprizone. It causes copper chelation, reproducibly demyelinates the brain. Okay, so we can cause multiple sclerosis reproducibly in weeks.
And then try to treat it, see if you can fix it.
But if you give those animals plasmalogens and proper dietary support, the cuprizone has no effect.
Wow.
Okay, so that means even while so you can be exposed to extreme toxins. If you can support your health structure, you can deal with it.
Treat the terrain. That's always naturopath said.
Same
Don't
thing
treat
with
the disease, treat the
Parkinson's.
terrain.
We had a lot of work in Parkinson's. It was an interesting story. These kids in their 80s were trying to make designer heroin.
Kids in the 80s?
In the 80s here in
I thought you
California.
said kids in their 80s.
No, yeah. In the 1980s,
Right.
there were some kids here in California trying to make designer heroin. And they made a byproduct called this MPTP, and they gave themselves Parkinson's. So there was a bunch of kids that went to the hospitals here in California with full-blown Parkinson's.
From taking this? Was it transient or was it
No,
for good?
for good.
Oh my goodness.
Right. But no one knew what it was. So there's a big detective story saying what this was, right? So they finally figured out that there was a byproduct. And so from that point period, we use this MPTP as a selective toxin
Interesting.
to create Parkinson's.
Have you worked anything in any kind of paralysis? Any kind of...
Not directly in the paralysis. Do stroke, for example.
Yeah.
Paralysis related to stroke.
Tell everybody what's happened with the stroke. Have you had them fully recover?
Yeah.
There's a lot of people benefiting from
like
this?
anything, the earlier you intervene, the better. Okay, but we have doctors in our clinics, in our centers. Our own personal experience with stroke is that we've had dramatic success in completely reversing stroke. So they leave the hospital and the person doesn't even know they have a stroke.
In the very beginning when they first had it? Or?
Yeah,
Wow.
and shortly after. So that means this acute brain, because stroke is basically like a TBI, essentially. It's a hypoxic stress to the brain. And then it can cause paralysis and, obviously balance issues, like those type of things, right? Or the face dysmorphia.
Distortion of the body.
And they can see that all come back to normal.
Wow.
So stroke and TBIs are something that...
Traumatic brain injury, TBI.
TBI.
I should have said that
Concussions.
before. Yeah, concussions.
Because what's interesting about those is that they're fairly acute. So if you have a concussion, the person is generally healthy otherwise, right? Like you don't have a prodrome to a concussion, like a car accident. Like it's, it's something that truly has happened to you.
Yeah.
And same thing with stroke, even though you have the cardiovascular component of it, right? It's still kind of typically hitting an otherwise functioning brain. And so if you can get in there and provide that support.
So you could really help I was joking a little bit before, but you could really help the football, the kids. And that's like, our kids are so important. You know how many kids go out there and play football as hard as they can, and they're taught to hit each other as hard as they can. So how many times a day when they hit their helmet on the other helmet, maybe it doesn't cause a concussion where they, pass out, but how many times do they have to hit each other before they start having problems, right? Do you guys study that? Do you have any studies with this or anything?
Well, we're going to do some studies. I don't have any direct ones, like other than anecdotal. Like we have just our case series of individuals, like random ones. And so large controlled trials. We're doing some animal studies with some universities in that regard. But the main goal will be in the community health model. So we'll treat these individuals. Now that we have advanced MRI technologies, we can measure and monitor individuals as they go. So you're already going to get a baseline MRI, and so you have this very objective. So we have these three objective areas of measurement. One is clinical symptomology, right? Like either they feel better, their symptoms get better, so you can actually see a difference in their clinical representation. Two, we have their biochemistry, so we can actually see the blood work becoming better. And three is the imaging technology, so the MRI. So we can actually objectively say, okay, we can measure the inflammation of the brain, we can measure the microstructure, and we can actually show it getting better. So I've published all this work. Like we did postmortem brain samples. We look at the in Rush University. We look at 100 brains with various levels of very highly accurate cognitive impairment levels. Okay. And we look at the membrane structure of those individuals. And so the plasmalogen levels of the brain are what determine your cognitive status. Interesting. Period. Okay, it's not open for question anymore.
Okay.
And so the question is now, the question, the amyloid plaques and the tangles, where do these things come from?
Yeah.
Your brain's not supposed to have them. Like no one's going to say, oh,
Well, it was from inflammation, right? It was
well, they come from two different areas. Okay, and I write about that in the book quite extensively. So amyloid plaques come from this membrane issue. This is why ApoE4 carriers will have higher amyloid plaque load as a general rule because of this cholesterol membrane issue and the plasmalogen issues in the membrane. And so that's where plaques come in, very highly correlated. So we can turn, just by increasing DHA plasmalogens, you reduce plaques, period. The neurofibrillary tangles come from the homocysteine system, if everyone heard of that, the methyltransferase system. And that's where these tau bundles, like these, there's transport systems in your brain that move material from the cell body to the end. It's like a tube, right? And the way the body moves things through that tube is like you squeezing a tube of toothpaste. It kind of creates a squeezing motion, like a peristaltic motion.
Mm-hmm.
And that's what these tau do. They're called microtubules. Mm-hmm. And then the on-off switch is this methyltransferase system. And that gets impaired in Alzheimer's. And so that drives that process. So that's why we talk about, in the proton scan, we measure the methyltransferase system very importantly. But yeah, those are not causal to the disease. Those are symptoms of the disease.
Right.
The actual cognition itself has been unambiguously determined since the 70s. Like we know without any question of a doubt that your cognition, your executive function, is driven by acetylcholine neurons. And we know that because we can see it in the brain, but I can give you an acetylcholine blocker. Like there's drugs of abuse, like devil's breath, for example. So which we use small amounts of it in medicine called scopolamine. And that will induce short-term memory loss. And it's used to abuse people. So if I give you some scopolamine, I can take you to the bank and you'll take all your money out and give it to me.
Wow.
And 2 hours later, you won't know what you did. But you'll still be moving around. Like you'd have no short-term memory left.
Yeah.
Like you'd be able to follow instructions but have no memory.
It's horrible.
And so, and that's all that does, all scopolamine does is it blocks acetylcholine. The acetylcholine system is absolutely the most proximate to your mental function. The issue is, why does that system degenerate with age? What causes that system to decrease? And the main cause is plasmalogen deficiencies.
Before the show started, you were talking about, you think that the human body should live to 150 years old, or it's possible.
I think it's indefinite.
Can you talk about that?
Personally.
A little,
So,
not in too many technical terms. Right?
Well, the biggest thing people think of is that they have the concept of aging wrong, or the concept of anti-aging wrong. Like they think of this picture of Dorian Gray. They want to go back to their 20s. Okay, but that's not possible. Like you can't go backwards. You have to adapt forward. And so you want to continually to age younger, continuing to age with more function, more knowledge, more capability. So you want to improve your function continually with age, which is what we all do when we work at a job, right? You start off as an apprentice, you become a journeyman, you become a master, you get better and better with time. Mm-hmm. Your body and your brain gets better and better with time, as long as you don't mess it up. And we talk about anti-aging, okay, or death, for example. And people, again, when we talk about the disease thing, they think that something is being thrust upon us. Like aging is being thrust on us. When it's not being thrust on us, our life has been taken away from us. And so there's actually no technical such thing as death. Like you actually lose your life, right? You either are alive or you're not alive. Mm-hmm. But I can't give you death. What I do is I take your life away. And so your functionality, so when we've got aging is a loss of function. Mm-hmm. And so if you maintain function, there's no clock. Like there's no age.
Telomeres?
But the telomeres, again, those are going to be adaptive to your cell system and your cell turnover rates and so on and so forth. Mm-hmm. And those telomeres do change. Same thing with your methylation rates.
So the telomeres aren't, like we measure it one day and they're short, and the next day they could be a little bit longer, like they fluctuate?
Correct, based upon your medical demands. So for example, if you stop working, you're sitting on your couch all day long, okay, you're going to use up less calories. You're going to have less energy requirements. Your body's not going to burn at the rate of a 20-year-old. Okay, it's going to say, whoa, this guy's not using all this energy. So it's going to start turning everything down. And all of these aging clocks that people measure, okay, they're actually,
Yeah.
they're putting, the cart in front of the horse, so to speak. Like it's not,
Well, they talk about chronologic versus biologic age, and they have a number of different mechanisms, biochemical mechanisms they're looking at. You don't put weight on that at all? You think that's
I think they're associative,
okay?
but not causative. So you can't say, okay, I can't go say, I'm just going to try to reverse my aging clock. And then if I reverse the aging clock, I am going to look and function younger. What happens is the opposite. You function younger and your aging clock goes backwards. Okay? Because the aging clock is actually monitoring your function, not your age. So, for example, the brain. So we do advanced brain imaging. So for example, I've reversed 20 years of my brain's age. Okay? Quantitatively, I can measure on MRI. My brain is no longer shrinking. I've restored the white matter. And so at a 56-year-old person, my brain should be shrinking since my mid-40s, okay, typically.
So you're back at 20 years before 56, you're saying, right?
Yeah, I'm in the 30, 40 range, yeah.
So you did go backwards in some respects.
Well, I'm not really going backwards. I've gone forwards.
Well, your health went forwards.
So
okay, all right.
If I'm going down here, then I'm going back up here, right?
Okay.
But I'm still, so you're not going to go back. So I'm not losing everything that I've gained in that 20-year period. Okay, I don't have to relearn all my 20 years of experience. So what I've done is I've maintained this healthy function, and I've restored my function to that of a 35-year-old, for example, right? And so this is the concept of aging. So you want to age forward. You don't want to reverse aging. You don't want to anti-age. You want to be able to continue to age forever, but maintain your function. And so this is the concept of people, again, they take this antagonistic approach where they say, I want to treat aging like it's a disease. Okay, and it's not. It's from a physics perspective, it's simply just entropy. Okay, it's all systems will try to reach some state of disorder, and we're always putting energy in to restore order. I tell people it's like making your bed in the morning. Okay, you get up in the morning, you make your bed, it looks great. Okay, everything in your life conspires to unmake your bed. You sit on the bed, it gets wrinkled. You put your clothes on the bed, it gets wrinkled.
Dog jumps on the bed.
Dog jumps on the bed, it gets wrinkled. And so what do? You go back and you smooth the bed out.
Yeah.
But that's you putting energy in. You are restoring energy. You're restoring order.
Well, you could
from
say
disorder.
that's prayer, and that's so many things, and
All these things.
Exercise, and eating healthy, and
It all
getting in
adds
the
up to that.
sunlight, and yeah.
But those aren't just enough. The human biochemical system, plasmalogens, other vitamins.
Used to be enough, maybe 100 years ago, would you say?
Not really. I don't think we've ever.
No.
What we consider our basal health, enough to not die, okay, is not the level of function that we need to sustain perpetual health indefinitely. Okay, so our food supply is simply not capable of supplying the nutrients in their full capacity that a human body needs.
Do you mean the food supply that's tainted now in this day and age, or the food supply ever?
Ever. Okay, so it gets you through, okay, but it's going to gradually tick away at you. Okay, so say, for example, riboflavin, okay, vitamin B2. Okay, probably 30% of the population is deficient in riboflavin, don't even know it, and probably eating fine. Okay, so the point is that you can be fine for a while, deficient, so you get knocked down for a little bit, you're okay for a while, and so over time, it starts ticking away at you. It's death by 1,000 cuts, so to speak, right? And so restoring and maintaining these healthy reserve capacities, okay, these are enough to get you by, you won't notice it. But when you're talking about long-term preventative maintenance, okay, take an automobile or take any kind of equipment that runs for very long periods of time. Those pieces of equipment are being maintained and fixed, even when they're not faulty. Right? There's preventative maintenance that's being done all the time.
Okay.
And it's maintained to a level.
So if we can say that your labs and your system will detect any of those things to prevent the 1,000 cuts, as well as eating healthy and and yoga or whatever you're doing. Then if you
having a purpose in
doing
your
your
life,
lab panel, seeing where you are, and then taking your supplements, you think you can keep them pretty even keel for a long time.
Absolutely. And then so and we're going to add more and more.
You're going to prove that, obviously, right? Or you have already in studies.
Exactly. Well,
you don't have any 150-year-old people yet, do you?
And by the way, it's fun to try. And we're going to add to that knowledge. Again, it's not. There's no magic pill.
Right.
It's a concept of providing function one step at a time.
I got a question for you, because when we saw some really great videos. It was A4M 2 years ago. It was a guy, it was from National Geographic from, you probably were there, it was the Blue Zones, remember? And the one guy's 101's water skiing. And they found out that it was mitochondria was the bottom line, but then there had to be a certain amount of flora. Dr. Gundry recently elucidated that some in his book. So what about that whole system? And why are those guys, they're not doing your labs, they're not taking plasmalogens, and they're 100 years old, and they're little Greek towns that eat totally healthy, and they have the support networks. What would you say about that?
Well, that's great, first of all.
No, it's amazing.
And but even if you take a look at maximum lifespan, okay, people have been living into their hundreds since the 1700s. It's like living to 108.
What? Really?
Oh yeah.
Way back then?
Yeah.
So I thought the lifespan was like 40 years old or 50
like so
years
in
old.
Sweden, like from 1700s to now, like the maximum lifespan has increased by about 8 years over the last 200 years. Okay, but so as you get more and more people, okay, you're going to have these rare cases where, you know what, they just got everything right randomly.
There was a lot of rare cases, though. They had like blue zones 5 or 6 or 7 all over the world. There's a lot of centenarians in each of those blue zones, though.
I agree with that.
I think there's just something more to it.
Well, I totally agree with that. But the point is they're still they're increasing by 10 years, 15 years, right? They're not living indefinitely.
For the average American, though, if he went through your system, and even if there was, well, because now we're looking at something we can't say, is there no cancer, there's none of this, just the average person doesn't have anything wrong with them, but do you think they can live to like 90 or 95 on your system if they're doing their labs, correctly, and they're taking the supplements you tell them to?
If people's health is maintained, absolutely. Like my dad's 87 in full functioning health, despite.
And you helped him with some problems already.
Absolutely.
Right? Okay.
And so, no, I don't see any reason whatsoever with what we're dealing with. And then as we develop more and more knowledge, we'll add more and more programs to it. But these core systems that are clearly associated with health and vitality are absolute musts. Like you have to get these things done right. And there are people that in the blue zones, like remember, your body naturally makes plasmalogens. So under certain circumstances, if you are making good plasmalogens and you live a life that has a low oxidative stress environment, okay, you're going to preserve those plasmalogens. Okay, it's a difference between long-term savings versus continual employment. Okay, so for example, I could be 70 and say I get 27-year-olds. Okay, this one has 100,000 in the savings account. This one has 10,000. This one has 1 million. Okay, I can predict if they both all three of them do nothing, they're going to run out of money at 3 different times later on. Okay, but if I take one 70-year-old, okay, and he's making $100 a month more than he spends, and he continues to make $100, and he's still working when he's 90, and he's still making $100 more than he's spending, and his savings going up and up and up. Okay, that's the person that you want to be. Okay, it's not about having a big savings account, which you do want to have, but you want to be continually adding to it. Okay, when you're in your 80s and 90s, okay, it's not about resting on your laurels of the past 10 years. You should be as healthy and continuing to be healthy going forward. I think this is the problem when people think retirement, and also when they start thinking aging, they're putting a time limit on their lifespan. Okay, they're actually saying I got X number of years to live.
Interesting.
Okay, and by doing that, you've already set your death date.
Yeah.
And really, the real issue is never retire. Plan on working forever or finding some purpose in your life.
Yeah.
Okay, and that's the perpetuality of it. And I think we think, oh, I've worked so hard in my life. I want to rest. I want my golden
work is
years now.
redemptive. If you go into spiritual, teachings, it's amazing. And when you work hard, you feel great. As long as your body's in good shape, you sweat, you get a lot of blood flow.
Exactly. And personally, like I really feel this ageism is one of my biggest pet peeves in the world. Like we discriminate against the elderly so disproportionately.
Here, I don't think in other countries, not as much.
Well, even then, like we don't, like to go to Japan, there's forced retirement. There's forced retirement in a lot of countries. Okay, there's not, like so, but this concept of, making room for the young, so on. And I really have an opposite approach to that concept. I think anyone who's worked hard to be good at something in this life, okay, you become 50, you become 60, you become 70, you become you've acquired knowledge and skill sets that then what happens is you lose your health. Okay, you don't lose your knowledge. Okay, these elderly people, they don't lose the intelligence. They don't lose their skill knowledge. They lose their physical ability to do certain things. And then that physical vitality loss results in society losing that huge amount of wisdom in that space. And I think as a society as a whole, if we started having, highly vital 80, 90-year-olds still working side by side with the younger generations, we wouldn't be losing this whole concept. History repeats itself because we don't remember history. Well, that's part of the generational thing, right? It's usually, it takes two generations. Like most people don't remember World War II. They don't think about it. They don't think about these things.
That's a big problem we're having now in the world, but that's another subject.
And they don't have any concept of the pain and suffering that can happen with certain circumstances. And part of that because that generation disappears. And so the next that generational knowledge gets lost. And one of the powers of humanity is this ability to pass on intergenerationally our knowledge. And so if we can expand the intergenerational transfer of knowledge and experience, we're all going to benefit. So that's my little that's part of the aging.
I agree with that. It's pretty cool.
Right? Think about it. Like we're just losing a lot of that transfer knowledge. And even if you're a company, if you're running a company, the last thing you want to do is lose your knowledge base, right? Your intellectual property. That's my basic philosophy.
Well, with that,
and as we're building through this process.
For coming on today.
Thank you, Dr. Dana.
My pleasure.